Hi everyone, my name is Nestor Crosa. I will explain, how to implement set intersection and union operation from scratch. Detailing the logic, the big O, or performance, and key test cases to validate our approach. Part 1, set intersection. The approach. Let's start with the intersection, which means finding the common element that exists in both sets. To solve this as efficiently as possible, we first identify which of the two sets is smaller. Then we iterate only through the smaller set and check if each of its elements is present on the larger set. If it is, we add to our result set, step by step. First, we compare the sizes of both sets. Let's call them set and set B. We define smaller as the one with the shorter length and larger as the other. We also initialize an empty set called result. We loop through each element in the smaller set. For each element, we perform a quick lookup to see if it exists in this larger set. If it does, we add the element our result set. Finally, we return the result set. Time complexity, big O. The time complexity for its approach is O minimum N and M, where N and M are the sizes of the two sets, because looking up an element is a hash set take average. O1, constant time, we are only bound by the time it takes to traverse the smaller set. Test case. To ensure this works robustly, I will test these three cases. Standard intersection, A with 1, 2, 3, and B when 2, 3, 4. The output should be 2 and 3. Completely disjoint sets, no common elements, I while 1, 2, and B while 3 and 4. The output should be an empty set. Only empty set A equal null and B equal 1 or 2. The output should be an empty set. Set union. The approach. Let's look at union with combines all unique elements from both sets. My approach to solving this efficiently is to create a brand new empty set, when then add all elements from the first set to the new set, followed by all elements from the second set. Since sets inherently do not allow duplicate, any overlapping element will be automatically and efficiently filtered out. Step by step, we initiate a new empty set called result. We loop through the first set, set A, and add every element to the result. Next, we loop through the second set, set B, and add every element to result 2. Since the set data structure handles duplicate removal under the hood, we don't need to write extra logic to check if an item already exists in both. Finally, we return the result set. Type complexity, big O. The type complexity of this algorithm is O n plus m, where n is the size of the first set and m is the size of the second set. This is because we must iterate through and insert every single element from the both sets to our new results, and each insertion takes O of 1, average time. Test case. To verify the union function, I will use these three test cases, set with overlapping elements A, 1, 2, 3, and B, 3, 4, 5. The final output should be 1, 2, 3, 4, 5, without duplicating the number 3. Identical set, I while 1, 2, and B while 1, 2. The output should be 1, 2. Empty sets. Both sets are empty. A and B are empties. The output should be an empty set. Conclusion. This concludes my proposed solution for both operations with optimal performance. Thank you very much for your time. I look forward to your feedback.